Hey guys, Marshall here. I want to share a recent project with you guys. This is my search and rescue payload that I've been working on for a medium to large size drone. It uses a Raspberry Pi 4 plus a Raspberry Pi high quality camera, a Google Coral, and a little extra circuitry for push buttons and LEDs. The whole goal for this project was to be able to create a semi-autonomous drone where I could mount this onto the system and use it to assist people who are operating in search and rescue. I live in northern Idaho, so people do get lost in the woods up here, and something like this may be just really helpful. But I thought also just a really fun challenge to try to put towards myself. As a demo for it, all I have to do is push the power button. The system itself will boot up. The red LED there shows that that Linux has booted. It's now operating, and the system is currently set up so that it will start recording as soon as it can. And once recording starts, it'll start flashing a green LED, which takes images from the camera into the Raspberry Pi, throws them through the detector, and then saves them down to the local SD card. Now you can see the detector's running, and then all I have to do is push the power button again, and the system will shut down. Now, over in the video, you can see where the detector algorithm is now identifying cars, trucks, traffic lights. It can also identify cats, dogs, people, bicycles, motorcycles. And so the idea is that now you can see where a small embedded computer can now see the world in the same sense that we can see the world. And that allows us to be able to automate and collect more data in our surroundings than we would normally be able to do. That being said, it's not perfect right now. There's things I want to do to be able to try and make it better. I definitely need to double check the focus on my lens. I'm worried that I might be a little out of focus. Otherwise, the lens intrinsics, so like pincushion or barrel distortion on the lens itself, can lend itself to having an effect on the algorithm for identification. In the video, you can also see where there's areas where JPEG compression is starting to distort what we're seeing. That shouldn't be affecting the algorithm or the identification, but it does make the end product that we're seeing not as pleasant. Things I do want to really try. Number one, I really want to play around with different resolutions to see how an increased resolution will affect the frame rate. Right now, it is operating at 14 frames per second, which is really fast for an embedded system like this. But I don't want to drop it too far. I want to be able to capture as much information as I can, and if I can keep the frame rate high enough, hopefully we can do some object tracking. Anyways, I hope you guys enjoyed this. This has just been something I've been working on for quite a while. It's been a lot of fun to do, and I just thought it was time to kind of try to show off what I've been working on. It's a lot of fun. I'm kind of hoping that I can get to the point where I can actually mount this on a drone and start showing off what the system could actually really do in a real life situation. I need to build the GPS library for it, but that's not going to take too long at all. Please let me know what you think. I'm really excited about it. It really has been a lot of fun to kind of go through and build something that's just kind of novel and interesting and see what I can piece together with just kind of hobby parts. And I've been really impressed with just the level of support that you're seeing for like TensorFlow on the Raspberry Pi, and like the support for the Google Coral, and just seeing how the entire hobbyist community is producing really, really high quality components. Along with the tutorials and the documentation that they put together is really next level. And so that's about all I have today. Thanks for stopping by, and please let me know what you think. Have a great day.